I'm gonna just do a little like overview what we've been doing so far. So grab your booklets and I'm gonna travel a little bit back and forth. If you go to page 29, that's actually where everything started, right? We started talking about trimmed mean. And why would we trim? Trimming means like we're literally cutting out values, the highest and the lowest, by the way. Like if you forget anything, usually if you just cut the highest and the lowest number, there's a 99% chance that you're going to get it right. Sometimes there are two outliers, which means you're going to have to cut the two highest and the two lowest, okay? But other than that, if you trim, you're fine. Why would we trim data? What's our goal here? To make it more accurate. And so what makes it inaccurate or not quite as representative? It's the outliers or the outlier, right? Most of the time there's only one, sometimes two. So you want to get rid of that. Like in this case here, in this case where the judges, you can argue that there are two outliers on either end, right? So you just trim them both. Like removing the highest and the lowest will just do the trick for you, okay? But with my examples, there's usually one outlier either on the top end or on the bottom end, on the tails, let's say, right? So we remove them to gain greater accuracy. So if the province or myself ever ask you, hey, do the arithmetic mean. The arithmetic mean is the one you've been calculating all along, which is including all numbers. The AM, okay, arithmetic mean. And then I ask you to do the trimmed mean, and then I ask you, see, which one is more accurate? Which one should you be using? You should remember, hey, it's the trimmed mean. The trimmed mean is the one you should be using because it removes bias, it removes any misrepresentation or skewing the data, right? Because of the outliers. The outliers actually skew it or bias. It's a bias, right? So go to page 30 here real quick. Page 30. We calculated the arithmetic mean and the median. So we were given this set of values and we just included all numbers. We got 4.17 as our average and our median was 2.7. Then we identified the outlier, which was 20.2, was very different. So we cut that one, but trimmed mean tells us we also have to cut the lowest because you can't just remove the high outlier because then it's out of balance, right? You kind of have to also make up and remove a little bit from the bottom. What happened to our mean? It significantly dropped, right? From 417 to 2.6, which you could have predicted, right? Because when you remove the high outlier, your average is going to go back down, right? Because this is pulling it up. This average is that high outlier is pulling your average up. But the median remained unchanged, which is going to be the case with trimming. I give you my, right? Did I do the scissors thing with this? Yeah, I don't want to do it again because then it's going to get too short. And then when we trimmed it one more time, like trimming 2 and 2, which this is just to make a point. I don't want you to do this normally. But when we trimmed again, there was very little change. Bless you. And why is that? Because, bless you again. Once you trim it again, like now the outlier is already gone, so trimming it even more isn't going to make a big difference anymore, okay? But the median, there's no change to the median, okay? So keep that. The mean is the most affected, okay? So can I say one more thing? Arithmetic mean, you include all values. As soon as you remove the highest and the lowest, we call it, you're looking up here, my red pen is right there, we call it the trimmed mean. It's no longer the arithmetic mean. So that's how we give them different names so that we know trimmed mean, you should right away know, oh, we removed values here, okay? All right, so come with me to page 31. And I'm going to ask you to write stuff down here. I left it blank intentionally. Page 31, okay? You're writing this down. I'm just going to give you one more time because when you review for the exam and whatnot, you want to have this written down. So recall, when it comes to these concepts, right? The arithmetic mean right, includes all values. Even the outlier, even the outlier or outliers. Trimmed mean omits the outlier or outliers by, make sure you write this down, removing an equal number of values from both ends, right? Emphasis on both ends. Let me just move this over a little bit. I will move my camera, okay? Just 1 second here. There we go. Because my book is about to fall over at the edge. Okay, so trimmed mean omits the outlier or outliers by removing an equal number of values from both ends. That's the key here. Okay. And then to conclude, the trimmed mean is more representative of the given scenario. Removing outliers removes a biased or skewed result. Oops. Trimmed mean is more representative of the given scenario. So removing outliers removes a biased or skewed result. However, I don't want you to write this down, but I just thought of it now. I'm just making this up right here as we speak. You ready? Which of these students do you think should ask for a trimmed mean as a final mark on the report card? Student B? How come? Yeah, he has a 0 Here she has a 0. The 0 is pulling your average down, right? So if you remove, so what would we have to do for this student here? We have to remove 0 and actually 70, right? This is the highest. So the lowest and the highest. So we find the average of these two. If we go up to student A, we would have to remove 100% and 50%, right? And then find the average of just those two there. So that's how trimmed mean works. Sometimes as a student you might not like it, right? Like in this case, for example, student A would not like a trimmed mean most likely because the 100 is helping you big time. And if I remove that, it's going to drop your mark most likely. We'd have to calculate it, but I put an extreme case in there. Everything else is the same, by the way, for both students. The first three that were the same, except for the last test, right? Got 100, got 0. But the 0 is probably very extreme. It's pulling you down quite a bit more. So student B would say, yeah, trimmed mean, right? He would root in the corner for a trimmed mean in that case. All right. So I'm going to ask you to try a few. So let's go over to page 32. Let's go to page 32 here real quick. I'll give you one more example, and then you're going to fly solo for a bit, okay? A data set contains the following values. So we've got, right, how many? 2, 4, 6, 7 values, right? 7 values. Let's write that down. That's odd. That's good to probably highlight. So what is it? If it says calculate the arithmetic mean, what does it say? What does that mean? That's the regular mean. Regular average. Let's put that down. So let's go ahead and find that real quick. X bar. I have the notes in front of me, so I know the answer, but I will just have that in front of me here. So 12 plus 5 plus 8 plus 10 plus 20. I'm already combining some numbers there. So that's 55 divided by 7. So if I divide that by 7, that's 7.86. We don't know what units are included in this case, so we'll just put units in this case. Okay. And then, can we do the median as well right away? I don't ask for it here, but let's just do the median as well. Let's put median down. It's odd, right? Odd said. So how do we find the median if it's odd? We just take 7, divide that by 2, we get 3.5, right? So it's going to be the fourth value. The fourth value is going to give me the median, but it needs to be arranged, right? So why don't we go up here and just arrange it right under here. You're going to have to be careful I get this right. 3, you think it's 6, okay. 4, sorry, 5, and then 3, 4, 5. 3, 4, 5, 6, 8, 9, and then 20. Okay, so this is the arranged set, and so fourth value would be 1, 2, 3, 4. It's this one. Yes, 6 units. So we got the median down. What about the mode? Is there a mode? Mode? Nope, none. Okay. All right, so now we're gonna actually break this here. Cut it right there. So I went mean, arithmetic mean, median, and mode. We didn't have a mode in this case. So now it says identify any outliers and calculate the trimmed mean. What's the outlier here? Outlier, I think, would be 20, correct? 20 units. can we write this arrange set down one more time? I feel like I want to make sure you can look back in your notes and know right away what's happening here. So I arranged it. I'm going to use my red pen. Sorry, it's falling apart here. The trimmed mean tells me I need to remove the outlier, correct? Some students just do that. And they're like, that's it, Mr. Dirks, I'm just going to find the mean right there. Nope. Removing that means also removing that. Equal amount of values on either end. Okay, so the trimmed mean is going to be, watch how I do this. 55 is much faster. Minus 20 minus 3. And how many values are left? 5. Right? So this is very important. There's only 5 values left versus 7 before. So this is 32. Yeah, 32 divided by 5. 6.4. Yeah, 6.4. 6.4 units. So let's compare before and after. Right? Did we expect a drop? You would say so, right? Because the higher outlier was pulling it up, removing it brings it down. Okay. Median. What's my median going to be now? I'm going to do this 4, 5, 6, 8, 9, because that's all that's left, right? I've removed these two. It's still 6. We don't even need to do the trick. It's still 6. No change. Okay, and the mode, there's still none. If there wasn't one before, there definitely won't be one. I shouldn't say that. I shouldn't say that. Sometimes trimming brings up a mode. Yes. So I have to be careful there. You have to look at your data, what's left. Okay. Here, the explanation, which if you want full marks with these questions, you got to make sure your explanation works well. Explain the difference between the arithmetic mean and trimmed mean, right? So AM versus TM. That's what you need to say, right? And you can come from either perspective, guys. You can choose which perspective you want to come from, right? The AM, right, is skewed since it will include all, watch, I'm going to switch it up on your data instead of values. It's the same thing, which will include all data, including any outliers. But it will be skewed or biased. Okay, skewed or biased. Trimmed mean is more accurate since it omits the highest and lowest values, comma, removing the outlier. There it is. All right. So I'm going to send you on a bit of a journey here. I'm going to tell you to work. I'm going to give you various pages. Your goal is to get as much done as possible, right? And I'm going to post the key. Pages 33 to 36. I want you to work through those. And I'm going to give you some, just watch for the warning that I'm about to give you, because there's the negative one, the negative example. Sorry, it sounds bad, the negative example. The example including negative values, okay? So if you go with me to page 34, there it is. You got to be careful. you got to be careful with this one. I'm interested in seeing how can you handle negative values, right? And another thing I want to tell you that the outliers are not always on the higher end. Sometimes they're on the lower end, right? But remember, 99.9% of the time, you will get the trimmed mean right by simply removing the highest and the lowest values, guys. If you do that, let's say you draw a blank, trimmed mean, you're like, what does trimmed mean? Oh, I'm trimming. What should I trim? Just trim the highest and the lowest, and chances are you're going to get it right. Okay. All right. So pages 33 to 36, I will post the key, and I will. Right. Before I go on to the next part, if you go to page 34, go to 34 real quick. You have to watch out with the negatives. So one way of doing it is just going plus, minus 4, plus, minus, like you can actually go plus or minus, like if you want. It's not needed. You can just type it in exactly the way you see it. It's negative 12, minus 4, and so forth. I think the critical part, so let's say go exactly the way it is, minus 12, minus 14, minus 5, and then there's plus 15, and then it's minus 8, minus 10, minus 12. Right? That's how I get my negative 46. And then I divide it by the 7 values, and you just got to make sure your temperature is actually negative, right? Because you're obviously that's your average. Otherwise, it's positive, right? Anybody know what a Chinook is or heard of it before? You've heard of it before? You live in Calgary, you experience those from time to time because you're close to the mountain ranges, right? And so it has to do with the wind pattern. But it could be, honestly, you could have 2 feet of snow and then all of a sudden you get that one plus 15. Like imagine plus 15 coming from like minus 12, 14. So that's definitely an outlier. You would not want to tell a friend that's about to move to Calgary, you wouldn't want to give him this, say, oh, on average, in January, it's like negative 6.57 or negative 6 degrees or so, because you're including the Chinook, which doesn't happen all the time. It's not like a weekly occurrence, right? It happens from time to time, okay? So on Wednesday, plus 15, right? We remove that. That's definitely where the Chinook occurred, and it's also our upper outlier. I call it upper because it's on the higher end, right? And so here you have to be careful. My key is probably like, what just happened there, right? I would just say make sure you remove plus 15, which is the highest, and negative 14, which is the lowest. Like you go back up here and just cross off those 2 days and then add up what remains. That's what I would suggest to you. But then you get a temperature of negative 9.4 Celsius, which makes sense because you remove the upper outlier, so your temperature drops on average, right? And so the trimmed mean would be the better indicator here since it removes the temperature of the day when the Chinook occurred, which is plus 15. Chinook is not a common occurrence, so it skews the average, which is a misrepresentation of the actual temperature, okay? All right. I don't want those temperatures, except for if you're into skating. If you like hockey, you're probably looking forward to some colder temperatures. My youngest son, he's a bit upset that it's so warm. And I'm like, no, it's nice. You'll get to skate in due time. Don't worry about it. But yeah, everybody has their preference, right? Okay, let's go to page 39. I'm going to stop this video here.